So now, through the magic of technology, we're going to skip ahead 10 generations, and we see that the car is doing fantastically well.
So here is
This
the first
graph is the
generation
same
of
graph I
cars.
produced
Actually,
in
the
my program,
0th generation.
with the red
looks
being
like they're
elite,
naming it.
the black being
And each
average,
of these is simply a
and in this case we're
random
trying to
selection of each of those
maximize
parameters.
success.
Random
So the
vectors,
score is
random
the
angles,
distance
random
traveled.
wheels, random sizes
And
of
our
wheels,
max
random
has
places of
increased
wheels,
dramatically
and
to
this is what comes out.
774. That
It's
was our
mostly
best
garbage.
solution.
This one, that one looked fantastic. That's unusual for a first generation. Anyway, when it stumbles across successful cars, those are used stochastically, of course, but with high probability to make the second generation, and the algorithm proceeds to make better and better cars. And here we are, through the magic of technology, we've skipped ahead, this time all the way to the 89th generation. And we are watching the best solution.
Okay, so before we get too enamored with genetic algorithms, let's take
maybe the car isn't something a human would design, but
here's some limitations and criticism
surprisingly well for something
based
as
I
only
several
on
times. The convergence mechanism is poorly
selection
understood.
and crossover
empirically,
and mutation.
We see it work
This
all
is
the time,
performing a fantastic
but we
job
lack
of
a solid
selecting
convergence
cars
theory.
that go the distance.
Next, it can get caught in local
That is the
minima
only thing they're being selected
or
for.
maxima, as the problem
And so,
dictates.
This is a fun thing to watch.
Next,
if
a
you
very
ever have
important
time
one. Genetic
and computer
algorithms
cycles
are
to burn,
often not the fastest
to,
available algorithms.
Boxcar
For our example with the
2D,
volcano,
and
the MATLAB
watch
function is
some
extremely
cars
fast.
breeding.
Even though my genetic algorithms function could be optimized incredibly to be so much faster, I still would not be surprised if the MATLAB function is faster than the fastest possible genetic algorithm. I can't prove that, but that would be my guess, because it's such a nice, clean mathematical formula. But for general problems, the fitness function could take hours or days for each call. For, say, you want to analyze the structural properties of a proposed building. That might take a while. Or some geophysical phenomenon. In any case, there are some situations in which evaluation of the fitness function is too cumbersome for genetic algorithms, which require many calls of the fitness function. And lastly, similarly, genetic algorithms do not scale well to problems of excessive complexity. I'm not sure at what point the complexity is excessive, but I guess try it empirically. A quote here that I think encapsulates the current state of genetic algorithms, from Stuart Russell and Peter Norvig's Artificial Intelligence, A Modern Approach. Quote, "In practice, genetic algorithms have had a widespread impact on optimization problems. At present, it's not clear whether the appeal of genetic algorithms arises from their performance or from their aesthetically pleasing origins in the theory of evolution. Much work remains to be done to identify the conditions under which genetic algorithms perform well." So we note that this is not a damning quote. It's simply a statement that we really don't yet understand them. Maybe we will. Maybe we'll come up with better models and theorems of convergence. But at the moment, it's an empirical algorithm, and that needs to be well understood before trying to rely on these too much. But that said, genetic algorithms have been applied to a staggering variety of problems: nonlinear dynamic systems, neural networks, robot trajectories. My favorite, evolving Lisp programs, having the functions in Lisp evolve themselves into useful programming structures. That's cool. TSP sequence scheduling. I've seen that a number of places, that for scheduling problems in general, genetic algorithms are extremely useful, extremely powerful, and many more. So genetic algorithms, though poorly understood, are extremely useful and extremely widely used and extremely powerful. Here is a quick list of my works consulted. If you would like more information, I highly recommend this first one, the Genetic Algorithms Tutorial. It's a fantastic tutorial with some useful Java applets to explore how the algorithm works. And again, the last one is very fun, Boxcar 2D. Give it a try.